So let's talk about electric potential. Now, electric potential is a type of potential energy. Just like, imagine if you, well, we were talking about before mass, if I have a piano and if I lift it up, it gains gravitational potential energy. And then if I drop it, it loses gravitational potential energy. Same here, if I have an electron, if I have a plate, which is on a positive, and if I take an electron away from that plate, if I let it go, then it's going to want to come back down to the positive plate. So it actually has a form of potential energy. And the amount of energy that we have, so when we often think about this type of thing, we imagine we have a charge at some infinite distance, believe it or not. So that's our zero reference location. And if I shift my electron from there to there, what is the change in energy? And basically what we can say is if there's a change in energy, electric potential energy, per charge, and we divide it by the amount of charge that we've got, that is going to equal, so this is potential energy, that's going to be in joules. This is charge in coulombs. This is going to be the voltage potential, or the potential voltage potential. And that's going to be, the unit for this is going to be joules per coulomb or volts, after the Italian physicist Volta. Now, the big thing to remember is often, if you have two charged plates, there'll often be a difference. So let's say this, if we have two charged plates, this might be 0, this might be plus 5. That plus 5 volts is basically how much potential energy is gained by a charge as you go from one plate to the other, or how much is lost. So the basic concept here, if there's a change in potential energy or a change in voltage, that change in voltage is going to be, when you position the change in potential voltage or potential energy, when you shift it from one position to another position. So the change in potential voltage is going to be the change in potential energy over whatever the charge is. So let's actually try a couple of examples of this. This is getting a bit philosophical, I know, but let's do exercise 4.5. How much energy is required to move plus 2 coulombs from a potential of 10 volts to 20 volts. So let's just draw a picture there. So here's our charge, which is plus 2 coulombs, which is freaking big charge. This plate, let's say we've got a plate here at 10 volts, we've got a plate here at 20 volts, and we're going to shift it from there to there. What is the change in energy? Well, the change in energy, change in voltage, equals change in EP over change in Q. We know what Q is. Q equals 2 coulombs, sorry, not 20 coulombs. Change in voltage. We know what the change in voltage is. Do we know what? Yep, we know what the change in voltage is. Whenever we talk change in voltage is equal to the final voltage minus the initial voltage, which is equal to, the final voltage is 20 volts minus 10 volts is equal to change in EP over our charge. We said the charge is 2 coulombs. This is what we want to find out. So that's equal to 20 volts minus 10 volts divided by 2 coulombs multiplied by 2 coulombs. So I can't even rearrange today. Equals change in EP. So that's going to be 10 volts times 2 coulombs equals 20 joules of energy. So basically, because remember the reason for this is it's 10 volts is equal to 10 joules per coulomb times 2 coulombs. Coulombs cancel, 20 joules. Okay, that seemed easy enough. Let's try something else. This is example 4.6. Remember, if you want to try this yourself, feel free to pause these and have a go yourself. It takes 20 joules of work. So remember, work is the change in energy to move negative 5 coulombs between 2 points. What is the potential difference? What is the potential difference between the points? What is the potential difference? Okay, so feel free at this point just to stick YouTube on pause for a sec if you want to give this a try. So remember, step one is we draw a picture. So we've got 2 plates. We've got our charge, which is going to be negative 5 coulombs. And we're going to shift it from there to there. One thing that's important about this, when we're talking about energy, it doesn't matter the route that it takes. It's just like a piano. If you lift up a piano, it doesn't matter if you lift it up like that or like that, the potential energy is the same. Same here. If I shift it this way or if I shift it that way, the voltage potential is going to be the same. So I'm going to shift that there, negative 5 coulombs. So again, we're going to use our change in V is equal to change in EP over change in times Q. Well, what do we know? We know Q is equal to negative 5 coulombs. We know that, what else do we know? We know the change in potential energy, change in EP, is equal to 20 joules. And all we can tell is the change in the voltage. So the change in voltage, don't even have to rearrange here, is going to be 20 joules divided by the negative 5 coulombs equals, what's that, negative 4 volts. So the difference between this plate, if we're shifting from here to here, the difference between this plate and this plate is going to be negative 4 volts. This could be 0 and negative 4, this could be, this could be 10 and 6. But basically the difference between this plate and this plate is there's 4 volts difference, and this plate's got a lower voltage than that volt. That's all we can do. So we can't actually say that's 0 volt. All we can say is this is 4 volts less than that. Hopefully that is useful. And just remember about potential energy, or when we're talking about work, remember work is equal to change in energy. That's the very definition. So if we say 20 joules of work is done, that means there's a change of 20 joules of electric potential. Cool. Okay, so good luck with that. I'll catch you in the next video.